For additional theory, thermal conduction is the transfer of heat energy in a material due to the temperature gradient within it. It always takes place from a region of higher temperature to a region of lower temperature. According to the law of energy or heat transfer, heat or energy always from the area of high potential to the area of low potential in free natural state or conditions. Heat from area of high potential to area of low potential in three different ways, which is conduction, convection, and radiation. From these three methods of heat transfer, conduction is the method of heat transfer which transfer between metals. For conduction is a mode of heat transfer from high potential source to low potential source of single body with the help of its vibrating molecule. For convection is mode of the transfer from high potential source to low potential source in fluid or from fluid. For radiation is mode of the transfer from high potential source to low potential source without the help of any medium.
Bismillahirrahmanirrahim and Assalamualaikum. My name is Muhammad Aiman Syahmi and I would like to proceed our presentation with apparatus and procedure for this experiment. Okay, firstly, the apparatus for this experiment is beaker, stopwatch, heat conductive plate, specimen of aluminium and beryllium, and lastly, the thermal conductivity of solid equipment. Okay, next for the procedure, we should start with measure the dimensions of the specimens and record the data. Next, insert the specimen into the thermal conductivity of solid equipment and clamp using the heating plate. Okay, next, set the temperature at 45 degrees Celsius and switch on the heater. After the temperature hits the 45 degrees Celsius, let it stable for 10 minutes for the temperature to stabilize. Next, when it stables, record the temperature of hot plates, cold plates, and heat flux value. And lastly, repeat the steps from 1 until 4 using the other different specimens like beryllium. Okay, that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Fikri bin Yusof. I am from Group 3 and I am going to explain the result and observation of thermal conductivity of solids. Okay, this is the result of the experiments. This is table 1, which we test of thermal conductivity of single layer type specimens. In this experiment, we only use 3 specimens, which is aluminium oxide ceramics, beryllium oxide ceramics, and lastly glass. From this data, we can see that the heat flux for all the materials are almost the same. For beryllium oxide ceramic and glass are the same, but the aluminium oxide ceramic have slightly different values. Okay, we can see that the thermal conductivity of beryllium oxide ceramic has the highest value, which is 17.02, and aluminium oxide ceramic has the lowest thermal conductivity value, which is 8.73. Meanwhile, the thermal resistance of glass is the highest among the three materials, which is 325.1, and aluminium oxide ceramic has the lowest thermal resistance, which is 117.21. Now we move on to table 2. Table 2 is for multiple layer type of specimens, and the specimen of aluminium oxide ceramics have 5 layers, beryllium oxide ceramics have 5 layers too, and glass have only 3 layers. The sum of the thermal conductivity is the thermal conductivity of all layers of the specimen.
The title
It
given for
shows
this
that the
experiment is
beryllium
thermal
oxide ceramic
conductivity of
have the
solid.
highest value,
So the main
which is
objective of this experiment is to determine the heat
51.0712,
conductivity of different
and
material given,
aluminium oxide ceramic
which
have the
is
lowest
aluminium
value,
oxide
which
ceramic,
is 26.19037.
beryllium oxide ceramic, and lastly the glass.
Next is
Even
transfer
though
rate.
the three
It
solids have
shows that the value
same
for all specimens
area,
is the same.
they have
That means
different
the heat
thickness
transfer
because of
through
the
all the
properties.
specimen through all the layers is the same. Now we move on to overall thermal conductivity and overall thermal resistance. We can see that the value of the thermal conductivity and thermal resistance is almost the same, or same with the thermal conductivity and thermal resistance of table 1. It shows that even its multiple layer, the thermal conductivity and thermal resistance of the material will not change.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adib Bezan Abidin, and I will continue the presentation. So the sub part that is given to me by our group leader is discussion. So I will present about the discussion. Okay, so from this experiment, when using the first material, which is aluminum oxide ceramic, with the thickness of 0.05 meter, the thermal conductivity of this material is the lowest, which is 8.73. Aluminum oxide ceramic also has the lowest thermal resistance. Although the thermal resistance for the glass is the highest, the thermal conductivity of glass is not the highest or the lowest, which is 12.54. It is the thermal conductivity of glass is between aluminium oxide ceramic and beryllium oxide ceramic. So so the discussion that can be made is, even though the solid have the highest thermal resistance, it doesn't mean that the solid has the highest has high thermal conductivity. So that's all from me. Thank you.